Welcome to my YouTube channel. This is Dr.Sengolrajan, Associate Professor in the Department of Electrical and Electronics Engineering from Konganadu College of Engineering Technology, 13th Tirupalli. I am going to discuss on the topic ultrasonic sensor belongs to sensor and transducers. Ultrasonic sensor is nothing but it is a sonic pulse signal. Ultrasonic sensor is nothing but a sensor which sends a sonic pulse signals, which is reflected by the object to be detected. Ultrasonic sensor, it is a sonic pulse signal that is reflected by the object to be detected. The time which the pulse signal requires from the sensor to the object and back is measured and evaluated. That is, ultrasonic sensor is a sensor which sends a sonic pulse signals which is reflected by the object to be detected. The time that is required by the pulse signals from the sensor to the object and back to the object is measured and evaluated. The distance is calculated from the time and the pulse speed. The distance is calculated from the time and the pulse speed. Ultrasonic sensors are suitable for use in different industrial environments such as dust, soiling, or fog, which do not influence the measurements. That is, the disturbances like dust, soiling, or fog, which do not influence measurements, can be measured. Interfering light influences or temperature fluctuations are not a problem when you're going to measurement with the ultrasonic sensor. The distance is calculated from time and the pulse speed. How you are calculating? That is, if you are sending the sonic pulse to the object, so from the origin of the source to the object and again from the object to the source, it will be calculated the time, what is the time required and the pulse speed that it travels. Then ultrasonic sensors are suitable for use in different industrial environments. Then the disturbances such as dust, soiling, fog, which do not influence the measurements are be measured. Hello, sir. கதிரிவேலம்மா சரி சார் ஓகே நான் பார்த்தேன் என்ன சார் சரி சரிங்க சார் ஓகே ultrasonic sensors. If you see the diagram, in this diagram, here is the source. You are generating the source. The source, from here you are emitting the sound pulse, that is sonic pulse. The time is being started calculating the time period. That from the source it started. It is going to touch on the object. Then again, when it touches the object, then here also the time is being noted. Then from the object, it is being returning back to the source. This is received. The echo is being transferred. When it reaches, the time period is being calculated. So this is nothing but an ultrasonic principle. That is, from the source, the sound pulses is being reflected onto the object and emitted back to the source. So the time period and the speed of the sonic pulses that travels is calculated using the distance calculation. Then here, if you see the diagrammatic setup, an echo time pulse. You are starting the time pulses with reference to the VSS power supply. It is been working. Then from this is the ultrasonic sensor. Here You are sending the sonic pulses, it is going to hit the object, then again it is been returning back. The echo is been returning back. So this will be calculated. Then the ultrasonic sensors, the distance travel is being calculated into the ultrasonic sensor is being calculated in three categories based on the distance. One is short range distance. The first one is short range distance. That is how we are classifying based upon the displacement. Then precision in terms of range. Precision instruments which measure optically in the range of 24 to 70 Precision instruments which measure optically in range from 24 to 70 using very advanced technology we are using. Precision short range distance means we are measuring 24 to 70 Then smallest deviations or even in the case of micrometer range will be detected. Then it is used in the electronics and automotive industries as well as in the areas of robotics. And coming to the mid-range distance sensor, then it ranges from 13 millimeter to 4 meter, 13 millimeter to 4 meter. The solution for measuring the ranges from 13 millimeter to 24 meter. So 13 millimeter to 24 meter. The solution for measuring the ranges is 13 millimeter to 24 meter, not 4 meter. Then here high-tech measurement instruments for customer requirements in the mid measuring range. Innovative sensor technology such as OES3 and time of flight measurement enable the solutions down to 0.1 millimeter. Highly precise and reproducible measurements are just as much a matter of course. Is extremely simple commissioning. Then coming to the long range distance sensor, it is developed a maximum range from 200 millimeter to 1200 millimeter. Coming to the applications areas of long range sensors, distance measurement to prevent collisions, detecting small parts at a large scanning distances, measuring differences, measuring diameters, measuring large heights, positioning parts, etc. Then here the sensors are distinguished by a high degree of dynamic performance and the precision of the devices, multifunctioning switching inputs and outputs, excellent background suppression, as well as user-friendly installations and alignment concepts. Robust designs as well as optionally available accessories ensure reliable use of the sensors even in harsh ambient conditions. Then here factory automations, logistics automations, and the process automations. Advantages of ultrasonic sensor. The first point is reliable with good precision. Reliable with good precision, not as prone to outside interference, not as prone to outside interference, good maximum range. Good maximum range. Fourth thing is inexpensive. The disadvantages sensitive to smoothness and angle to obstacles. Sensitive to smoothness and angle to obstacles. Poor resolution. Then prone to self-interference from echoes. Self-interference from echoes. Cannot detect obstacles too close. Cannot detect obstacles too close. So these are the disadvantages. That's all. Thank you. We will meet in the next video.